Hello, Math 45 students. This is your instructor, Cindy Enrique, and we are going to go ahead and dive into Chapter 8. So Section 8.1 is all about circles and ellipses. So here we have the equation of a circle. It's in standard form, where it's x minus h inside parentheses squared plus y minus k inside parentheses squared is equal to the radius squared, where r is the radius and we have the center hk. And of course we have the circle, the actual diagram over on the right hand side. So notice how the center is HK and the radius is anywhere from the center of the circle to one of its sides. That would be the radius. If I went all the way through, then that would be the diameter. Okay, so let's look at example number 1. It says find the center and radius of the circle, then graph the circle. Well, by looking at our notes up above, we have our general equation where we have the x minus h squared plus the y minus k squared is equal to the radius squared. So because we have that outline, I know exactly what my h and k is going to be. I can say that my h value is going to be exactly 3. And my k value is going to be -4. And my radius, well, my radius squared is 36, so then the radius must be 6. So I'm going to go ahead and write that out. So my center, and remember the center is h and k, so I have my 3 and -4 as my center. And you also have your radius as equal to 6. So therefore, I have identified my center and the radius. So now I'm just going to have to graph this. So my center, I said, was 3, -4. So there is my 3, -4. And then because my radius is 6, that means I'm going to go out 6 in every direction. So I'm going to go up 6. 1, 2, 3, 4, 5, 6. I'm going to go down 6 from the center. I'm going to go to the right 6 from the center. And I'm going to go left 6 from the center. So now I have my up, down, left, and right from the center that I'm going to go around. So now I just have to connect those dots to go around as a circle. So it might not be very pretty, but I'm just kind of giving a rough outline. So maybe your guys' circles might look a little bit neater than mine. I'm writing on my notebook, so therefore it's a little squiggly, but more or less that's my circle. It doesn't have to be exact, but I at least have the graph of it. Okay, well, I hope that helps. And I also have, for example number 2, the exact same question where I'm finding the center and the radius of the circle. So just keep rewriting it until you have it memorized, your standard equation of a circle. So you know that it's x minus h squared plus your y minus k squared is equal to your radius squared. So now that you have that, it's looking somewhat familiar. You can see that you can rewrite this equation. You can rewrite it as x minus 0 squared. That doesn't change anything. And you have your y minus 10 over 3rd squared. And the radius here is your 25 over your 9. So I just really wanted to make sure that you notice that just because you have that x squared, it doesn't mean that you don't have an h value. It just defaults that your h value is going to be 0. So now you have your h value and your k value. So now your center, since it's your h and your k, you have that pinpointed. So your h value here is 0. And the k value is going to be your 10/3. And well, you can see here that your radius squared is equal to 25 over 9. So then your radius is going to be the square root of both those things. So remember, to undo a square, you square root it. And so you're going to have 5/3. So this is what my center and my radius looks like. And it just might be helpful if you write it as a decimal, just to help you. So let's see what 10/3 is as a decimal. So I would have 10 divided by 3, which is a 3.3 repeating. And your radius, since it's 5 divided by 3, that's about a 1.6 repeating. So it doesn't have to be perfect, but let's see what this looks like. So I have a 0 and a 3.3, so somewhere over here. And my radius is a 1.6. So I'm going to go over 1.5. So my circle, more or less, just a rough estimate, is going to look something like that. Okay. Now, for example number 3, it says find the center and the radius of the circle and then graph. So we have x squared plus y squared plus 2x minus 16y plus 61 is equal to 0. So here, what we're going to do is we are going to make sure that our goal is to write it in that standard form, which is the x minus h squared plus the y minus k squared is equal to my radius squared. And the only way to do that is by using the completing the square. Okay, so I'm going to rewrite this, and I'm going to rewrite this with subtracting 61 on both sides. So I'm going to group my x's together, and then I'm going to group my y's together. So here I have an x squared, and over here I have a 2x. So x squared plus my 2x. And so I'm also going to have a y squared and a negative 16y. So positive y squared minus 16y is equal to, and I did 0 minus 61, so it's a negative 61. So now I have the constant on the opposite side, and I also have my x's grouped together and my y's grouped together. So hopefully, if you remember the completing the square, what that looks like is going to be the x minus the b divided by 2 squared is equal to your constant plus your b divided by 2 squared. Okay, so that's kind of our general outline of our values. So then here, my b value for the x's is 2. So when I do my b divided by 2, well, 2 divided by 2 is 1. And if I were to square that, 1 times 1 is 1. And so if I do that for my y values, I have a 16. So 16 divided by 2 would give me an 8. And if I were to square that, that would give me a 16. So now I know exactly how this is going to play out. I have my x, and that b divided by 2 value is going to be a plus 1 squared plus, and now I'm looking at my b divided by 2 value for my y's, so y minus 8 squared, and it's equal to my negative 61, which I already had, my b divided by 2 squared, which we said was 1, as well as that positive 16. Or sorry, I made a mistake here. What's 8 squared? So remember, 8 times 8 is 64. So I should have said 64. There we go. That makes it a little bit better. So now I'm going to have this as x plus 1 squared plus my y minus 8 squared. Now I'm going to add all of those numbers together. So I'm going to have a negative 61 plus 1 plus 64, which is a positive 4. So that is my general equation. So now I can tell you that my center would be -1, positive 8, and that my radius, well, remember that the radius squared is equal to 4. So if I were to square root that, my radius would be 2. So now I have my graph. So I know my center is at -1, 8. So -1, 8 is there, and my radius is 2. So that means I'm going to go up 2, I'm going to go down 2, to the right 2, and to the left 2. So that is what my circle looks like. Okay. Well, I hope that helps, and I hopefully that you guys remembered how to do the completing the square. If you guys are forgetful on the completing the square, please look that up on a previous section, or go to Khan Academy, or go to the web and look up completing the square if you have forgotten how to do that, okay? Or you can also email me as well, that's fine. Okay, so the second part of section 8.1 is all going to be about the ellipse, okay? So the ellipse is a set of points x, y in a plane such that the sum of their distances from two fixed points is a constant. Each fixed point is called a focus, or a foci for plural. So more or less, this is what one of the ellipses is going to look like. Sometimes we're going to be looking at ellipses at the origin. That means the center is at 0, 0, and not the origin. So just know here when it says centered at the origin, that is specifically saying that the center would have been at 0, 0, okay? So when it's not at the origin, that means not, the center is not 0, 0. Center not at 0, 0. That's what it means for it not to be at the origin, okay? All right, so here is all the important information that you're going to need in having to deal with an ellipse. So we have the general equation. So let's look at it first when it's centered at 0, 0. When it's centered at 0, 0, you're going to have x squared over a squared plus y squared over b squared. And this is when a is bigger than b. So this is what it's going to look like. Versus the second part, if I have x squared over b squared plus y squared over a squared, and that means that the a was greater than the b. So it just kind of depends on which denominator is bigger, okay? So that's kind of the difference between the two. So which denominator is bigger will determine type of ellipse. Okay, so I hope that kind of helps you out. And we also have something else, and that something else is called the foci. Okay, so here it says the foci is related by the equation where c squared is equal to a squared minus b squared. So I just really want to make sure that you guys see that as the foci, okay? And figure A is the horizontal ellipse at 0, 0, and part B is the vertical ellipse. So the horizontal ellipse, that would be like my type 1. So that would be this one. So my ellipse more or less would look like this, versus my ellipse here would look like that, okay? So it's stretched out horizontally, versus the second equation is stretched out vertically. Okay. So now looking at the first example, it says, hey, identify the vertices, the co-vertices, and the foci of the graph. So you're like, okay, so all you're really doing is just looking at what's happening. So we want to identify the vertices first. So the vertices. The vertices are the endpoints. So this would be the vertices. So we can say that the vertices are at -9, 0, and +9, 0. The next thing that we're going to think about is the co-vertices. The co-vertices are going to be along the opposite axis. So that's here. So those are your endpoints, okay? So you're going to have your, co-vertice. So the co-vertices at 0, 4 and 0, -4. So the last thing that I want to talk about is the foci. So the foci is going to be the one slightly near your vertices. So this would be your foci. So it's not on the edge, it's more on the inner part of your graph. So that is going to be my foci. So -√65, 0 and √65, 0. So I have my vertices, my co-vertices, and my foci. Okay, so the next thing that we want is sometimes you're not going to be given the equation from a graph. You're just going to be given it to you as a formula. Okay. So we want to identify the vertices, co-vertices, lengths of major and minor axes, and the foci of the following ellipses, okay? So let's do it for part A for sure. We may or may not run out of room for part B. So really, the way I'm going to be doing this is by making sure that I have this page very handy, okay? So page 4 is really telling me how I'm going to be coordinating everything. So it all depends on which denominator is bigger, and it will determine how I'm going to be calculating the vertices, the co-vertices, and the foci, okay? So let's think about this. So it says identify the vertices, co-vertices, and lengths of major and minor axes. So let's look at the denominator. I have a denominator of 25 and a denominator of 9. So this denominator is definitely bigger. Since that denominator is bigger, then I'm definitely going to be looking at the general equation where I have the x squared over a squared plus my y squared over b squared equal to 1. So because I'm looking at that, then I exactly know what my a squared is going to look like. So my a squared is equal to 25. So that tells me that a is equal to 5. Likewise, that tells me that b squared is equal to 9, so my b is equal to a positive 3, because the b squared is just your denominator of the y squared, okay? So with that being given, then I'm able to do the calculations pretty easily. So it says to identify the vertices. So if I have the, let me make sure I plug in my computer here. Sorry about that. Okay, so if I'm looking at my vertices, so let's think about this. Let's even look back at your chart. So since this denominator is bigger underneath the x, then I know that I'm looking at this first equation. So to look at the vertices, it says that it's plus or minus a, comma 0. So I'm going to go ahead and write that down. So I know that my vertices would be plus or minus a, comma, 0. Well, in that case, since I have my a value, that should be plus or minus 5, comma, 0. So those are going to be my vertices, the plus or minus 5, comma, 0. That's what I have. Now, for the second part, it says that I want the co-vertices. Well, for the co-vertices, that's my 0, comma, plus or minus b value. But I already know my b value. My b value is 3, so that's a plus or minus 3. So now I have my co-vertices. Okay, so there goes my co-vertices. Now it wants the length of the major axis. So okay, lengths of the major axis. So that major axis, and remember I have all the equations up above, it's 2 times a. So in this case it would be 2 times 5, so that would give me 10. So that the major axis is equal to 10. Now I want the minor axis. Well, the minus axis is going to be 2b. So 2 times my b value, which is 3, is equal to 15. So my minor axis is going to be, what is 2 times 3? 2 times 3 is not 16. Sorry, 2 times 3 is really 6. There we go. That makes more sense. Your minor should definitely be less than your major. So that's a good thing to check there. Your minor should be less than your major. So 6 should definitely be less than 10. So your major you got by 2 times a. Your a value is 5, so 2 times 5 is 10. Your minor you got by 2 times b. Your b value is 3, and 2 times 3 is 6. Okay, so then the last thing I'm going to need is the foci. So for the foci, you have a certain formula. Your foci is going to be plus or minus c, comma, 0, where you have that c squared is equal to a squared minus your b squared. Well, you already know your a squared, that was 25, and you already know your b squared was equal to 9. So now you have c squared is equal to 16. If you square root that, that would be 4. So now you know that your foci is going to be plus or minus 4, comma, 0 for your foci. Okay. So that gives you all of your information for your vertices, your co-vertices, lengths of the major axis, length of the minor axis, and your foci. So that is everything you need to know for part A. So we're going to do the exact same thing for part B. So we're going to see the difference, okay? So again, we want to be looking at this denominator. So here, let's see what we have. The denominator is bigger in the y. So this denominator is bigger. So we're going to be following a different outline, slightly different. So we know the outline that we're going to be looking at is the one that we have x squared over b squared plus y squared over a squared equal to 1. Because that tells us that this, oops, that's not what I wanted to do. But it tells us that this 49 is bigger, so that is going to be our denominator because it is bigger. So that's going to change our value slightly. So now I know that I'm going to have that my b squared value is 16. So the square root of 16 is 4, which is going to tell us something else, that our a squared is equal to 49, so that the square root of 49 is 7. So now I have my a values and my b values, so now I can go ahead and put this into play. So now I'm going to be figuring out my vertices. So my vertices is outlined as a 0 plus or minus my a value. So in this case, it would be 0 plus or minus my a value, which would be 7. So those are my vertices. The next thing I want to be looking at are my covertices. So my covertices are outlined as plus or minus b, comma, 0. So plus or minus b would give me a 4, comma, 0. So it's positive 4, 0 and negative 4, 0. And of course, I'm going to be looking at the major axis. So the major axis here, I guess I didn't write that down, so let's look at that. So the major axis, the length of the major axis is 2a and the minor is 2b. So that did not change. So I'm going to have this as 2 times my a. So 2 times my 7 would give me a 14. So that would be my major axis. Versus the length of the minor axis is 2b. So 2 times my 4 value is equal to 8. So the minor axis there would give me 8. Okay. So the next piece of information that I need is going to be my foci. The foci here is given to me as a 0 plus or minus c. And that value doesn't change, or that equation where I have c squared is equal to a squared minus my b squared. So my a squared was given to me as 49, and my b squared is given to me as 16. So c squared is equal to a 33. So c is equal to the square root of 33. So then my foci is going to be this plus or minus the square root of 33. Okay. So I hope that gives you a lot of insight into our problems here. So it really just kind of depends on which denominator is bigger. It depends, so whichever denominator is bigger, then that's kind of the equation or the format that you're going to be following. So whether it's going to be stretched out horizontally, or if it's going to be stretched out vertically, is going to tell you where the vertices are going to be lying and the covertices, and of course how to get your foci as well. Okay. Well, let's look at this first example. It says, what is the standard form equation of the ellipse that has vertices 0 plus or minus 5 and covertices plus or minus 3, comma, 0. Okay? So here, let's think about this for a minute. I have my vertices as 0 plus or minus 5. So here, the vertices, that first value is 0. So since that first value of 0, let's think about this. So I am here. So let's look at these vertices. So here are the vertices and here are the vertices. So if I have 0 in that first spot, then it's going to be plus or minus a. Okay? So I'm looking at this type of equation for this problem. So you're just like, okay, perfect. So I know that I'm going to have plus or minus a. And it's going to be going along the vertical axis. So now I know that my a value is equal to 5. Perfect. And now that covertices, since it's plus or minus 3, comma 0, well again, if I look at this over here, I know that the covertices is plus or minus b, comma 0. So this tells me that my b value is equal to 3, which is perfect, okay? So that general equation that I have is going to be my x squared over b squared plus y squared over a squared is equal to 1. So since I already know that my a value is equal to 5, then a squared is equal to 25. And I already know that my b value is equal to 3, so b squared is equal to 9. So now I just plug it into my equation. So I have x squared, and now I have my b squared. So that b squared value is going to be 9. Plus, now I have y squared divided by my a squared. And my a squared value is equal to 25. And the ellipse is always equal to 1. So that is going to be my equation. Okay. So for the next example, it says, what is the standard form of the ellipse that has vertices plus or minus 8, 0 and the foci plus or minus 5, 0? So here I have my value of a over here. So I have that a is equal to 8. So a squared is equal to 64. I also have this as my c value. So I have that my c value is equal to 5. So c squared is equal to 25. And remember, the general equation of the foci is that c squared is equal to a squared minus b squared. So it's very easy to figure out what the b squared value is going to be. So I have my 25 is equal to my a squared value, which is 64, minus my b squared. So now I am going to subtract. So 25 minus 64, and that is going to give me a negative 39, is equal to my negative b squared. So if I divide by a negative, then I would get that 39 is equal to b squared. So b is equal to the square root of 39. And since I have a, 0 as my vertices, then I know that my general equation, so this is going to be stretched out along the horizontal axis. So I'd have the denominator bigger underneath the x. So x squared over a squared plus y squared over b squared is equal to 1. So now I just plug in my values. So x squared over my a squared, which is my 64, plus my y squared over my b squared. That b squared value is 39, and it's all equal to 1. Okay. Well, I hope this is all very helpful for you guys. And now we get to do this with a graph. So we're just going to be graphing the ellipses here. So the first thing we want to do when we graph the ellipse is going to be the center. So here, the center, since there isn't anything with the x and the y, we can think of it as a center of 0. So this is my center of 0, 0. So this is the center at the origin, 0, 0. So I know my first initial center is 0, 0. Okay? Now let's look at the denominator on x. So here is my denominator of x. So that's going to be 9. What is the square root? Oops, don't want to do that. The square root of 9 is 3. So that means along the x-axis, I'm going to go over 3 in each direction. So 1, 2, 3 to the right, and 1, 2, 3 to the left. Okay? Now I'm going to look at the denominator on the y-axis. So I have the square root of 25. That's equal to 5. So that's how far up and down I'm going to be going. So I'm going to go up 5 and down 5. So now I have the general equation and the general shape of my ellipse. okay? So because it's longer along the y-axis, then I know that these are going to be my vertices. So I can say that my vertices are plus or minus, it should be 0, comma, plus or minus 5. So then my co-vertices, the shorter side of the ellipse, is really plus or minus 3, comma, 0. Okay. And the foci, if I wanted to graph that, that would be that c squared is equal to a squared minus my b squared. So a squared is equal to 25. And my b squared would equal to 9. So 25 minus 9 is 16. And the square root of 16 is 4. So my foci would be then 0 plus or minus 4. Okay, so now I have labeled everything. So now I have my vertices, my co-vertices, and my foci all on my graph. So what I like to do is just graph everything first, and therefore I can tell you my vertices and my co-vertices just by looking at it, and then it just takes me, 3 lines to figure out my foci, okay? All right, so that is that. For part B, what makes this a little bit sneaky is that we know that all ellipses should equal 1. Okay, so this is not 1, but we can force it to make it look like 1. So I have my 4x squared plus my 25y squared equal to 100. So since I want it to equal to 1, I'm going to divide it by 100, because 100 divided by 100 is 1. So that means everything gets divided by 100. So when I do that, I'm going to have an x squared. 4 divided by 100 is 25. And 25 divided by 100, I'm going to get a 4 on the bottom. And we did 100 divided by 100 is 1. Now we can happily say that this is an ellipse, okay? Now, by looking at this, I know a couple of things. I know that my center is at 0, 0. So there's my center, 0, 0. Along the x-axis, the square root of 25 is equal to 5. So that means I'm going to go out 5 in each direction. Okay. The next thing I see is the denominator of y. So the square root of 4 is equal to 2. So that means along the y-axis, from the center, I'm going to go up 2. And from the center, go down 2. So now I have more or less the shape of my ellipse. So remember, wherever it's longest is going to be your vertices. So here and here are your vertices. So I can say that my vertices are going to be plus or minus 5, 0. So the co-vertices are along the shorter side. So the co-vertices were 0, plus or minus 2. And now for the foci, well, I know that the foci has a general equation where c squared is equal to a squared minus my b squared. So my a squared that I'm going to be plugging in is 25. And the b squared that I'm going to be plugging in is 4. So 25 minus 4 is 21. So c is equal to plus or minus the square root of 21. So my foci is going to be plus or minus the square root of 21, comma 0. And the square root of 21, let's just get an estimation. So if I plug that into my calculator, the square root of 21, the decimal approximation, is approximately 4.58. So let's just say it's about 4.6, the square root of 21. So if that's the point, then if that's the case, and I know it's slightly past 4, so let's say that's going to be here. So that's going to be my foci. Okay. Well, I hope that helps in how to draw these ellipses and these circles. Okay. So now we're going to be dealing with ellipses not centered at 0, 0. So now the center is going to be a little bit off, but the general idea still kind of remains the same, okay? So it says, what is the center and the vertices, co-vertices, and the foci of the ellipse? So let's start at the center. So the center is going to start here, what's being added and subtracted by, okay? So here, my center is going to be -3, 5. So I have my h value and my k value. All right. So now I'm going to be dealing with what is my a value and what is going to be my b value. So notice how the denominator on y is bigger. So if the denominator on y is bigger, then I'm going to be looking at this one. So bigger denominator. So I know that's going to be the equation that I'm going to be looking at. So that is something that I'm going to be paying attention to. So I know that my a squared value is equal to 100. So that a is equal to the square root of 100, which is 10. Which tells me that my b squared is equal to 4. So my b is equal to 2. And we should go ahead and give you the h and k values since it's already given to us. We have our h and k. So just so that you guys can see it, h is equal to -3. And we have that our k value is equal to a +5. That's just going to help us when we identify some other things. So for the center, we have that. Perfect. Checked off. Now, the next thing we want to do, maybe, is going to be our vertices. Okay? So if I'm thinking about the vertices for this is going to be h, comma, k, plus or minus my a value. So let's think about that. Well, my h value doesn't change, that's -3. The k value is fixed to be 5. And that a value there is 10. So I'm going to have my vertices as -3, and I'm going to actually kind of figure this out. 5 plus 10 is 15. And the other one is -3, and now I'm going to have 5 minus 10, which is going to give me a -5. So now I have my my vertices as a 3, 15, and a -3, -5. okay? So that is how I did that with that k plus or minus a value, and that a value was 10. So I had to add 10 and I had to subtract 10, okay? So now I've dealt with my vertices. So now let's deal with our co-vertices. So for our co-vertices, that is going to be the general equation of our h plus or minus b comma k. So, okay, let's see. Our h value was -3, and our b value is 2, and our k value is fixed at 5. So now I'm going to go ahead and work this out. So I'm going to have -3 plus 2, and that's a -1. So now if I have -3 minus 2, that's a -5. So that is going to be our co-vertices. And so the last thing that it really wants us to do is going to be our foci. So okay, here's our foci. So for our foci, we have h comma k plus or minus my c. Well, first I have to kind of figure out my c value. So I know that's going to be c squared is equal to a squared minus my b squared. So my a squared value was 100, and that b squared value was 4. So 100 minus 4 is 96. So that tells me that my c is going to be plus or minus the square root of 96. So the h value was my -3. My k value was 5. And now I have plus or minus the square root of 96, since that is my c value. So I can say this is, actually, I can just leave it as that. So now I have my center, my foci, my vertices, and my co-vertices. Okay. So remember, I'm just keep going back to that general equation. That's how I'm getting these formulas, and that's what's really helping me out here. Okay, so the next example. It says, what is the standard form equation of an ellipse that has vertices -8, 2 and 6, 2 and co-vertices -1, -1 and -1, 5? So when I look at this equation, I can see something that's going to help me here. I have my vertices. And what's really cool about this is that the second ordered pair is the one that is fixed. So I'm going to scroll up to where I would be referencing. So I want to make sure that I'm looking at my vertices where that second value is fixed. So not the x, but the y value, okay? So let's go back over here and think about this. So here are my vertices. So this is what I'm looking at. So which one is it where the y value is fixed? Well, that would be this one. Because this y value down below, it would have it as k plus or minus a. That means that these are going to be different. Versus this k value tells us that the y value is fixed for the vertices. So now I know what type of equation that I'm looking for. So now that I identified the equation, now I can actually use that to get this information. So I know that the general form is going to be the x minus the h squared over my a squared plus my y minus my k squared over my b squared equal to 1. So that really kind of helps me out to figure out what the general form is going to be. So because that's the general form, I can go ahead and give you some information based on that. So now that I have the general formula, I have a lot of good information here. So let's think about this. So now that I have the vertices and the equation, I can start piecing some things together. So I know that the vertices are going to be h plus or minus a, comma, k. So that tells us that if I have negative 8, 2, and 6, comma, 2, at the very least my k value is 2. Likewise, if I go over and look at the covertices, the general formula for the covertices would be my h and k plus or minus my b value. So since that's the case, I have negative 1, and I have negative 1. Let me rewrite that. That looks a little sloppy. Here we go. Right, a little bit better. Negative 1, and negative 1, comma 5. So now I can tell you without a doubt that my h value is equal to, not k, but to negative 1. So the h value is equal to negative 1 from my covertices, and from the vertices I get my k value. Well, I also know the center is h, comma, k. So here the h value is negative 1, and my k value is 2. So now I know my center. So when I rewrite this, I'm going to have x plus 1 squared over my denominator plus my y minus 2 squared over my denominator equal to 1. So what I need to find is my a squared and my b squared. So I know that is what I need to find. So let's think about this for just a little. Oops, sorry about that. So let's think about that. So since I have my covertices where it's plus or minus b, then I know a few things. I know that I'm going to have that 2, since that's my k value. Since k is equal to 2, then I have that k plus b is equal to a positive 5. Okay? So 2 plus b is equal to 5. So b is equal to 3. And b squared is equal to 9. Okay? The reason I got that is because k plus b is equal to 5. I also have that k minus b is equal to a negative 1. So my k value being 2, plus, and my b value being 3 should give me back that negative 1. And it does. Let me rewrite that. So k minus b should equal to that negative 1 value. So 2 minus 3 is equal to a negative 1. So it definitely works out that my b value is equal to 3. So that tells me that the b squared is equal to 9. So that b squared is underneath the y. So I'm going to have this as a 9. Okay? And that all came from using that k plus or minus b. Okay. Alright, so now to get that a squared value, that is going to come from using this. It's going to come from using that h plus a over here. So it should equal to negative 6. Sorry, it should equal to negative 8 and positive 6. So I'm going to have h plus or minus a is equal to, well, let's actually make a decision here. Let's say I'm going to have plus a. If I have plus a, then it's going to equal to my positive 6. And I already know my h value to be a negative 1. So now I know that a is equal to a positive 7. So if I square 7, that's going to give me 49. So now I know that I have x plus 1 squared over 49 plus y minus 2 squared over 9 is equal to 1. Okay. So it all came down from identifying my h and k value from the vertices and the co-vertices, and then kind of plugging that in, so I have my center h and k, and then figuring out my a and b depending on what the vertices and the co-vertices were given. Okay. Now for the second example, it says, what is the standard form of equation of an ellipse that has these vertices and foci at these points? So again, I'm going to be referring to the formulas up above. So looking at this, it looks like the vertices are at -2, -8, -2, and +2. And the foci being at -2, -7, and -2, (1). So here, what I'm going to be focusing on is the vertices. And it looks like it's fixed on the first ordered pair, so I guess the x value of the vertices. So let's think about that here for a second. So if I'm looking at the vertices, so here are my vertices, and I am looking for it to be fixed. And the one that I want to be fixed is going to be that h value, that first ordered pair. So that looks like it's going to be this one. So this is the equation that I am going to be looking at. So I have it where x minus h squared over b squared plus y minus k squared over a squared is equal to 1, because that first ordered pair on the vertices, the h value is fixed. Okay, so that's how I know I'm going to be using that type of equation. So I know that the equation, the general equation, is going to be x minus h squared over b squared plus y minus k squared over a squared is equal to 1. Okay, so now pieces of information that I already know. So I know that whenever I have the vertices, it boils down to a certain formula. And that formula is going to be h, comma, k plus or minus a. So I for sure know that since that h value is fixed, h is equal to -2. Okay? And I actually have those numbers. So I have -2, -8, and I have -2, comma 2. So what that tells us is that I have k plus a is equal to a +2, and I also have that k minus a is equal to a -8. So using this information, I can actually do a substitution. I can figure out that here, let's say I want to get this a isolated, k is equal to, I'm going to subtract a from both sides, so I can get that k is equal to 2 minus a. So I'm going to do a substitution. I'm going to plug this equation into here. So I have k minus a is equal to a -8. So what I'm plugging in here is that 2 minus a. And what I get is 2 minus 2a is equal to a -8. So I'm going to subtract 2 from both sides. So I can get that a -2a is equal to a -10. Now if I divide by -2 on both sides, I can get that my a is equal to a +5. So now I have that a squared is equal to 25. So perfect. So what I know is that my h value is and my a value is. So now I can deal with my foci information. So for the foci, I know that that general equation was going to be h, comma, k plus or minus my c value. So here, that h value that hasn't changed is that -2. and here I have a -7 and a +1. So what that tells me is that I have k plus c is equal to a +1, and I also have that k minus c is equal to a -7. And here I already know what that k value is. That k value was equal to 2 minus a, and that a value that I got was 5. So I know that my k should equal to a -3. So to get my c value, I just plug in my k value. So k, which is -3, plus c is equal to 1. So my c value, if I add 3 to both sides, is equal to 4. Let's just make sure. So -3 minus 4, that's equal to a -7. So that checks out. So now I have all of my important pieces of information. I have my h value at -2, and I have my k value at -3. I have my a squared at 25, and it looks like the only thing I need is my b value. So for that b value, remember with the foci, I have c squared is equal to a squared minus my b squared. So here, c squared, that would be 4 squared. That a squared is 25 minus my b squared. So I'm going to have 16 is equal to 25 minus my b squared. So I'm going to go ahead and do this. So I'm going to have my 16 minus 25, which is a -9, is equal to a -b squared, which tells me that 9 is equal to b squared. So now I know that my b squared is equal to 9. So now I can go ahead and write down my specific equation. I have x plus 2 squared over 9 plus y plus 3 squared over 25 equal to 1. And that is going to be my final answer. Okay, well, I hope that helps. And if not, like I said before, you guys can email me. Now it wants us to go ahead and graph these equations below. So let's start at the center. So at the center I have h and k. So here my h value is going to be a -2, and my k value is going to be a +5. So I have -2, +5 as my center. That is going to be the middle of my ellipse. Now for the vertices, I like to do it, or I like to read it once I graph it. So the denominator on x is 4, and the square root of 4 is 2. So along the x-axis, I go 2 to the right and 2 to the left. Okay? And so for the y value, that denominator is 9, so the square root of 9 is 3. So along the y value, I'm going to go up 3, and from the center, I'm going to go down 3. So now I have the shape of my ellipse. Okay. So I can definitely see that it's longer along the y-axis. So I'm going to say that my vertices, and it's going to be here and here. So that vertice is -2, 8, and I have a -2, 2 for my vertices. Now I can tell you about my co-vertices just by looking at the graph. It looks like it's 0, 5, and it's also -4, 5 as well. Now the foci may be a slightly more tricky. I'm going to rewrite that 5. I don't like the way that looks. There, that's a little bit better. Okay, now I can definitely tell that that's a 5. So don't forget that your foci is going to be your c squared is equal to a squared minus your b squared. So c squared is equal to your a squared, which would be 9, minus your b squared, which would be 4. So 9 minus 4 is going to give you 5. So your c is equal to plus or minus the square root of 5. Let me write that square root a little bit better. So your c value is going to be plus or minus the square root of 5. And don't forget that your foci, the general of that, is going to be your h value. And then you're going to have your k plus or minus your c. So my h value here is -2, and my k value is 5 plus or minus the square root of 5. So I have it at -2, and I have a 5 point. So 5 plus or minus the square root of 5, so that's a little bit beyond 5. So -2 and a little bit above the 5. Well, actually, let's see what the square root of 5 would be. So let's actually calculate this. So 5 plus the square root of 5, that gives me, let's see, 5 plus the square root of 5, that's approximately 7.23. So if I did 5 minus the square root of 5, that's approximately 2.76. So that just helps me to kind of verify where this value is going to be. So at -2, I have about a 2.76. So that's about here for my foci. And then -2 and about 7.23. So that's about there. So those red dots represent my foci. Okay. Well, I hope that helps. Now, let's look at part B. So for part B, remember, we want the ellipse to always equal to 1. That is your goal. So goal, set equal to 1. The other thing that we're going to do is the completing the square. And that was the x plus b divided by 2 squared is equal to -c plus b divided by 2 squared, in case you forgot. Okay, so I'm going to rewrite this, and I'm going to clump my x's together. So here's an x, and here's an x. So I have a 4x squared minus 40x. Now I have my y's that I'm going to be dealing with. So I have a positive 9y squared plus 36y. And I'm going to subtract 100 from both sides. So this is equal to a negative 100. Okay. So now from here, I am going to factor and help myself out when I do these problems. So for the first one, I can factor out a 4. So I have an x squared minus 10x. Over on this one, I'm going to factor out a 9, so I can have a y squared plus a 4y. And this does not change the value of a negative 100. The reason we do this is because whenever we do the completing the square, we always want your a value to always equal to 1. That is what completing the square, the very first step is. You always want to make sure when you're doing the completing the square that your leading coefficient is 1. So that is what we're doing. So now we're going to put this into play. So I'm going to have 4. And I'm going to do this over here where it's equal to a negative 100. So now I'm going to have x minus, now let's think about this. If I have 10 here, what is 10 divided by 2? So I have my negative 10. I'm going to divide that by 2, which gives me a negative 5. So that is the b divided by 2 value is a negative 5. So that is what I'm going to have here. So when I square that, negative 5 squared is equal to a positive 25. So I have to add 25 to the opposite side. Not only do I have to add that 25 to it, but I also have to do something else. I also have to multiply that 25 by the number out in front. That number out in front is 4. So I have to account for this number as well. So you have to be careful about that. So it's 25 and then times by that number out in front, which is a 4. So let's see if we can do that again with our blue. So we have plus 9. And over here, I'm going to have 4. Divide that by 2, which is 2. So that is my b divided by 2 value. So when I square that, that's 4. But it needs to get multiplied by the number out in front. So that's going to be 9. So plus 4 times 9. Okay? So let's see what that gives us. I'm going to have 4x minus 5 squared plus 9y plus 2, oops, and I forgot the squared up there, equal to, and now I'm going to put this all into play. So I'm going to have a negative 100 plus 25 times 4 plus my 4 times my 9 is going to give me a positive 36. And remember, we always want to set it equal to 1. So since I want it equal to 1, I'm going to divide everything by 36. So that way I can get a 1 in there. So I'm going to have my x minus 5 squared. 4 divided by 36 gives me a 9 in the denominator. I have my y plus 2 squared. 9 divided by 36 gives me a 4 in the denominator. And 36 divided by 36 gives me a positive 1. So now I know that my center is going to be 5, negative 2. So I'm going to go down to positive 5 and negative 2. So that is going to be the center of my universe. Now, along the x-axis, I'm going to go left and right along the x 3. So 1, 2, 3 to the right, and 3 to the left. Now, for my y-axis, I have the square root of 4, which is 2. So from the center, I'm going to go up 2, and from the center, I'm going to go down 2. So now, more or less, I have the shape of my ellipse. So you can see that along the x-axis was longer, so that's going to be my vertices. So my vertices was going to be 2, negative 2, and 8, negative 2. Versus my co-vertices are in blue. So that is going to be 5, 0. Now I have 5, negative 4 for my co-vertices. And so for my foci, that's where I'm going to do a little bit more work, and that's okay. So your foci is c squared is equal to a squared minus my b squared. So I'm going to have c squared is equal to my a squared, which is 9, minus my b squared, which is 4. So 9 minus 4 is going to give me 5. So then c is equal to plus and minus the square root of 5. So that tells me that my foci, that ordered pair is going to be 5 plus or minus the square root of 5, comma, negative 2. So let's see. If if I have 5 plus the square root of 5, that's going to be about 7.2. And 5 minus the square root of 5, that's about 2.76. So I know that my foci, since it's 5 plus or minus 5, that's going to be about 7.2, negative 2. So there's my first foci. The other foci is 5 minus the square root of 5, so that's about a little past 2, but before 3, and it's down at negative 2. So that is going to be my foci. Okay, and so that brings us to the conclusion of section 8.1. So this is a very long section. It's a lot of information. So if you guys got stuck, hopefully you guys can rewatch the video, or you can contact me, or you can contact the embedded tutor, and you can also contact the Math Success Center and schedule free online tutoring. So there's a lot of different resources. It's up to you to use them. All right, good luck.